which basically boils down to probability using shapes. Probability using shapes. Now here is a for example. A good example would be going out to the archery range. You have a target, and usually there's a bullseye in the middle. And the question would be, if you hit the target, what's the probability of getting a bullseye? Okay, I suppose I probably have to give you a little bit of some dimensions here. Do I get dimensions? Did they give me a dimension? Sure. Radius of the large circle is 10. This big circle here, the radius is 10. And the radius of the small circle, let's say, is 6. So from here out to here is 6. Now, how do you suppose that you're going to find that probability? Anybody? It's a pretty simple thing. What, Spaniel? It's a 6. Can you not read that? It's a 6. 6 is the radius of the small circle. And there it is. 10 is the radius of the big circle. How would you find out the probability? Well, it's pretty simple. It is simply the area of the small circle over the area of the big circle. Okay, because you have that total area there that you can find, but you only can hit this part of it there. And that maybe, it looks like a hard thing, but it really shouldn't be that hard, because you know that the area of a circle is what? Pi times radius of the small circle, and over the pi times the radius of the big circle. And the beauty of this is, since both of them have pi's in them, it's going to make the math a lot easier in the end. What is the radius of the small circle? 6, correct. And what's the radius of the big circle? 5 times 10 times 10. And it's a good thing, 8th graders, since you are at this level of math, for you to understand. You always want to try to make your life a little bit simpler in doing these long calculation sort of problems. So before you do all this math out and make 3.14 pi and all that stuff and try to divide it all up, look for things that'll cross-cancel first, because that'll save you a lot of time in the multiplication. For example, Jeremy Schwartz says, yeah, a pi over a pi will cross off. They're the same thing, 3.14 over 3.14. What about the 6's and the 10's? Can 6 and 10 be reduced, or does some number go into both of those, Lauren?
2 goes into.
Alright, 2 goes into 6 3 times, 2 goes into 10 5 times. And the same thing over here, 2 goes into 6 3 times, 2 goes into 10 5 times. That's about all that you can do. And when you remultiply, you get 9 over 25. And that would be your probability of hitting the bullseye. Now, is that really true if you're shooting an arrow? You know what? It depends on how good of a marksman you are, would change your probability. But if you're blindly just pointing your bow at the target, you should hit a bullseye 9 out of 25 times, just randomly pointing there, because this bullseye takes up 9/25 of the space of the whole target. And they're just saying, well, blindly, if you're shooting here, you know, you're going to hit here, you're going to hit here, maybe hit here. You know, 9 times out of 25, or 1 out of almost every 3 times, you're almost blindly going to get a chance to hit the bullseye. So it's a little like playing the lottery. They use that phrase that somebody's going to win, it might as well be you. Everybody's got the same percentage chance of getting it, but that percentage is so small that the chance of it actually being you is more never.
So it's like pin the tail on the donkey kind of probability?
That would be it. Lauren hit it right on the nose. It's kind of like pinning the tail on a donkey where you spin and you're pointed in the right direction and you just blindly go up there and push something there. That would be exactly it. Because there is some skill. If you're talking about archery, there's going to be skill involved in it. You know, you're going to have, if you guys, those archers who are in the Olympics are going to hit the bullseye, 90% of the time. So this is just a blind, random sort of thing here. Now, another example of this right out of the book, write this one down. Let's say you've got a square here, and then inside you have another square like this. And the dimensions of the outside one are 14 by 14, and the dimensions of the inside one, let's say, are 10 by 10. Okay. Again, the probability is going to be, and you have to watch what question they ask. You know, let's say you've got this shaded. There'd be two different answers I could ask. I could say, what's the probability of landing in the shaded region, or I could ask you the probability of landing in the not shaded region. Either one of them, it just would be flipped around. Probability of the shaded region would be the area of the shaded part over the area of the whole thing. And there again, you just write down area of a square is, the shaded square is going to be 10 by 10, correct? Area of the non-shaded one is 14 by 14. And again, rather than sitting there and doing the multiplication and doing the division, look and see what you can cross cancel first, which is what, Jackson?
Divide by 2.
Cut them both in half. This is 5 over 7, and that is 5 over 7, giving you a result of 25 over 49, which is very close to half, by the way. Half of the time, which makes sense because these look like they're going to be about the same little parts there. Was 15 over 15, would it be exactly half? You've got what? 2 fifths, 420 in a row. It doesn't sound that hard, does it? Let me give you one to try. What about this one? You've got a square with a triangle in it. And the dimensions of the triangle are 6 and 8. And the dimensions of the square is 10 by 10. What is the probability that you will land in the triangle? Probability of the triangle. I will give you a second to figure out. This is actually not that incredibly difficult. So, as a matter of fact, it should be relatively simple. As you generally do. Probability, you are just blindly playing pin the tail on the triangle. The triangle is on that square piece of paper. What are you telling? What happened to the rest of this paper? What do you want in that paper? Huh? You have to what? You have to what? Lucas Espanol says,
Yeah, 4/25.
anybody else get 4/25? Oh, Lucas. Kala gets
6/25.
6/25. Anybody else with 6/25? Oh, Lucas. Let's see where we went wrong here. First of all, you've got the area of a triangle over the area of that square, right? And the area of a triangle is 1/2 base times height. The square is just side times side. So it's 1/2 of 6 times 8 over 10 times 10. Interestingly enough, did you do some reducing beforehand? Sure, why not? 2 goes into that 3 times, into that 5 times, sorry. 2 goes into this 4 times, into that 5 times. You get 3 times 4 is 12. Half of 12, Lucas? 6. 25th seems to be the answer. Where did you go wrong, Lucas?
I did a third, because I was thinking of the area.
You were thinking of cones and such, not just things. So this ain't terribly difficult, is it? I didn't think so. What happened to page 600? Enough of that.